In this problem, we're asked to graph f and g, which are defined here and here, in the same rectangular coordinate system. Then find the point of intersection of the two graphs. I'm just going to go over how to graph them. So I want to graph 6 to the x and 6 to the negative x. I start by clicking here to enlarge the graph. 6 to the x is an exponential function, so I'm going to select the exponential curve, and it requires that I place a point that's on the graph of the exponential curve. Well, a point on every exponential curve in standard position is over 0, up 1. So I click there, and this box opens up. This is where I can indicate what the base is and all of these transformations. If I want to vertically stretch or shrink it, if I need a vertical shift, a horizontal shift, if I want to reflect it over the x-axis or the y-axis, and the base. So right now I'm just graphing 6 to the x, so I just need to indicate that the base is 6. So that is the graph of 6 to the x. Now let's graph g of x, which is 6 to the negative x. Recall that a negative in front of the x will shift it, reflect it over the y-axis. I start by graphing another exponential function. So I select the exponential tool, and I needs a point on every exponential in standard form is over 0, up 1. I click there, and this box opens up. So I need to first indicate that my base is 6, and then that negative in front of the x means reflect over the y-axis. So when I click this box, this graph will reflect over the y-axis. Watch. And that's the graph of 6 to the negative x. And that's what you're asked to do in the first part of this problem, to graph f and g in the same rectangular coordinate system. Note that it is not asking you to graph the asymptotes.